Hello, grade 7. So this is the chemistry revision worksheet. These are the answers. First of all, I want you to stay safe, okay, in these turbulent times. I would love for you to do these questions only because it's a nice summary of what we've been doing in this semester for semester 1. I've concentrated on what we've been doing on the last 2 weeks, which is homogeneous and heterogeneous mixtures. So please do these questions. Obviously, any questions that you want or need can be answered in the class. Just do these questions to the best of your ability and good luck. Question 1. So it says, use the words in the box below to label the hazard symbols. Remember, this is our good old hazard symbols. Okay, we learnt this in the very beginning of our chemistry. I only did this so we can refresh our memories. I was very nice to you and I gave you the words in the box. You have to use the words in the box. I know that you probably revised them a bit different, okay, but yeah, because I gave you words in boxes, you have to use the words in the box, okay? This is just for you to know that you have to work with what you're given, okay? So some of you like to work with what you know. Sometimes that you can't do that. You have to use with what you're given. So number 1, remember this image here is corrosive. So there's the word corrosive. The second one is gas under pressure. So the second one is gas under pressure. This image is gas under pressure. Third one, wherever it looks like an explosion, like an explosive bomb, is called explosives. And then we have the circle with the flame, okay, not the flame by itself, the circle with the flame is called oxidizing. Remember the exclamation mark is caution. Now then we have the fish that looks like it's drowning in pollution or in the sea. It's dangerous to the environment. Yes, I know that you know it as aquatic toxicity, but I haven't given you aquatic toxicity as a option, okay? So you have to know that this could be also dangerous to the environment, okay? The process of elimination, or you can see that this is an environmental hazard, okay? So please, it's really important to use the words in the box, okay? Then we have just the flame. When we have just the flame, it is flammable. Also, when we have the human with something going on with him, like star inside him, this is, okay, you know it as health hazard. Here I've written for you long-term health hazard. So please write long-term health hazard. And then we have the skull. This is toxic, okay? So this is how we do our hazard symbols. Question 2, matter. Matter is a substance that occupies physical space. According to modern physics, matter consists of various types of particles, each with mass and size. Matter exists in 3 forms: solid, liquid, and gas. Using the text, answer the following questions. Please, when it says using the text, don't use your own knowledge. Yes, we know that matter is anything that takes up space or size or volume. It's not the definition I want. I want the definition, which is the first sentence here. Matter is a substance that occupies physical space, because it says using the text, okay? When it says using the text, please use the text. Then it says, using your own knowledge, answer the following particles. Draw a schematic representation of the particles found in the states of matter. Remember, solids are close to each other. I'm going to try to do 2 or 3 more. Okay, you see how they are very close to each other. Okay, they've got no room to move. Liquid are far from each other. Okay, I'm going to draw 2 more. Okay, so liquids are far from each other, while gases are very far from each other. Okay, so gases are very far from each other. So this is how we draw the particles found in a solid, in a liquid, and in a gas. Substance X melts at 80 degrees and boils at 320 degrees. Determine the physical state of X at. Now, for this we have to draw a array. Remember, we draw a line first, then we put 2 lines. First of all, it says melts. What does melt mean? It means it goes from solid to liquid. So here we're going to write solid, and here we're going to write liquid. Okay? So this line here is then the melting. Here, this line here is the melting point. What is the melting point? It's at 80 degrees. What does that mean? Anything before 80 degrees is solid. Anything after 80 degrees is liquid. Then we say the word boils. What does boiling mean? It goes from liquid to gas. So boiling is liquid, written right liquid, and then it goes from gas. So this here line here is the boiling point. So what does boiling point happen at what degrees? It happens at 320 degrees. What does that mean? Anything before 320 degrees is still a liquid. Anything after 320 degrees is a gas. So we need to determine the physical state. Remember, physical state means solid, liquid, or gas. So at 40 degrees, so we said anything after 80 degrees is anything before 80 degrees is a solid. So at 40 degrees, it's a solid. At 75 degrees, this is still before 80 degrees, is also a solid. At 320 degrees, okay, 320 degrees is this point here. So it's still in between liquid and gas. It's transforming into gas. This is why the answer is liquid and gas. At 342 degrees, this is right after 320 degrees. So at that point, our substance X is a gas. Complete the following table by putting an X on the right answer. So oxygen, this is really easy, we've done this. Oxygen gas, it even says gas, so it's a gas. Table is a solid, and chair is a solid, and water is a liquid. Okay, this is just to refresh our memories a bit. Question 3, again, is about matter. So we spent a lot of time on matter, this is why we've got 2 questions about it. Read the following text. Matter, especially pure substance, is composed of atoms. The arrangement of particles in matter depend on the physical state of the substance. In a solid, particles form a compact structure. Okay, so look how we drew them. Okay, here is we've got a compact structure that resists flow. The particles in a liquid have more energy than those in a solid. They can flow past one another, but they remain close. Particles in a gas have the most energy. They move rapidly and are separated from one another by relatively large distances. Okay, so this is just an introduction to our question. Use the information provided and your acquired knowledge to complete the table below. So we've got solid, liquid and gas, and we want to see the shape and volume. So let's look at the shape first for the solid. The shape does not change. That means it has a definite shape. With liquid, the shape changes. So if I have 2 beakers, for example, if I have a cylinder beaker and let's say a round bottom flask beaker or container, what will happen is that if we pour water from the cylinder beaker into the round bottom flask, it will take the shape of the round bottom flask. Okay, so we say it's got an indefinite shape. That means the shape always changes, okay? Wherever you put, it just takes the shape of the container. Gas also takes the shape of the container, okay? So the shape changes. Remember, if we have a small box, it will take the shape of that small box. If we have a big box, it also takes the shape of that big box. Okay, so you can change the shape of the gas. Volume. The volume does not change, so the amount of space. The volume does not change for a solid. If you have, for example, a rubber, it's not going to suddenly take more space. It's not going to suddenly increase its volume. We say it's got a definite shape. Also with the liquid, if you've got 20 milliliters of water, it's not going to suddenly become 30 milliliters of water. So also the volume, the amount of space it takes does not change. We also say it's got a definite volume. Now, for gas, remember I sprayed perfume in the classroom and then the smell of the perfume went everywhere. Okay, this is because the volume changes of a gas, it spreads. The gas particles like to take all the amount of space that they can, okay? So we say that the volume, the space it takes changes for a gas. So we say it's got an indefinite volume. The volume always changes. Scientists distinguish two types of physical properties that lead them to distinguish pure substances from each other. These physical properties are distinctive and measurable. Define each one in no more than one sentence. Remember, we looked at distinctive and measurable, and it's in your book if you can't remember them. So what is distinctive is something that you can describe. Okay, so if I was going to describe water, I would say it's clear. Okay, so we can talk about the odor, how does it smell? Okay, for example, petrol's got a distinctive smell. How does it taste? Okay, and what's its color? It's something that I can describe. For example, I can say orange juice is orange. Okay, it's got the color of orange. So this is what distinctive is. Measurable is something that is measured in the lab. For example, the melting point or the boiling point. For example, water has a boiling point of 100 degrees. That's something that we can measure. Density, for example, water has a density of 1 gram per centimeter cube. Okay, so this is what we mean by measurable. It's something that we can measure. Okay, normally performed in the lab. So fill in the table below to give examples on each. So color is a distinctive property. Boiling point is a measurable property. Density is a measurable property. Taste is a distinctive property. Melting point is a measurable property, and odor, which is also known as smell, is a distinctive property. Okay, so these questions as a nice summary of what we mean by distinctive and measurable. Okay, these are really important for you to understand. So please revise these very well. Our last lesson was about homogeneous and heterogeneous. So look at these three beakers. We've got sand, table salt, and sand and table salt. The same volume of water was added to each of the content of each of the above beakers. So here we added water, here we added water, here we added water, here we added water, and here we added water. And it's the same level of water in each. So infer if the sand would dissolve in water with the table salt and with the sand and the table salt. So the sand does not dissolve in water, the table salt will dissolve in water, and the sand will not dissolve in water, but the salt will. Okay, so even if we add sand and salt and water together, the sand won't suddenly dissolve or the salt won't suddenly not dissolve. Okay, they still will have the same physical properties. The sand will still not dissolve and the table salt will still dissolve. Now, justify the type of mixture. That means if it's homogeneous and heterogeneous obtained in each case. Let's justify. How do we justify? We just say if it has one phase, more than one phase, two phase, okay? So A, which is just when we put the sand, is heterogeneous. Why is it heterogeneous? Because we have two phases. What are the two phases? We have the sand, which is a phase, and the water, which is a second phase. Okay, so this is why it's heterogeneous. B is a homogeneous because only one phase is observed. Remember, the table salt dissolves in water. We can't see the salt separately and the water separately. No, we only see the water. So therefore, only one phase is observed, which is the water. So we call this homogeneous. While C is heterogeneous, because yes, the table salt does dissolve in the water, but we still can see the sand. So that we can see two phases. Therefore, C is still a heterogeneous mixture. Given the following six mixtures, so here we've got six mixtures which are labelled A, B, C, D, and E, and F. We have to use the letters to classify the above mixtures into pure substances, heterogeneous mixture, and homogeneous mixture. Remember, pure substances like water, so normally don't interact chemically, like water, oxygen, nitrogen. These are all pure substances. Heterogeneous mixtures is something that when the two substances do not mix, therefore we see more than one phase. Homogeneous is when the two substances mix, so therefore we only see one phase. So first of all, we have water and sand. Remember, we said that the sand and water do not mix, so therefore it is a heterogeneous mixture. So there we go. This is where we've written A in the heterogeneous mixture. B is distilled water. Distilled water is a pure substance. Then we have salt and oil. So salt and oil do not mix. Salt does not dissolve in oil, so therefore it is also a heterogeneous mixture. Then we have water and nail polish. You can do this at home. Okay, so if you add water with nail polish, they mix, so it's an homogeneous mixture. Acetone and nail polish as well. Acetone is the same as nail polish. Okay, these also is a homogeneous mixture. Then we have vinegar and water. You can also try this at home. They mix, so this is also a homogeneous mixture. So this is the end of our questions. I hope you do well, and please stay safe.